We are going to do a virtual density lab today, but first I need to tell you a little bit about density. Density is how much something weighs for its size. For example, in the picture here are two pieces of metal. The one on the left has a mass of 49.3 grams. The one on the right has a mass of 18.6 grams. But wait a minute, they're the same size. It turns out both pieces of metal are actually solid metal, but they are made of very different metals. The metal on the left is heavier for its size. It is denser. So in this lab, we're going to compare the density of large and small pieces of wood. So first, we are going to deal with a large block of wood. Weigh the large piece of wood on the scale. Record the mass on your lab paper. So as you see, the mass of this large block is 210.3 grams. It is very important to put a unit on your paper. Next, measure the length, width, and height of the block in centimeters. Why are we doing this? Well, the formula for volume is length times width times height, and we need to know the volume of this piece of wood. So, here is a ruler measuring the length of the block of wood. We will want to get at least one decimal place. So you see in the picture in the close-up that it's 24 point something centimeters. So we read that carefully and we can see it's 24.9 centimeters. Next, we need to find the width of the block of wood. Go ahead and record that in your notes. That would be 4.4 centimeters. And finally, the height of that block of wood, which would be 3.7 centimeters. Now, it's very important that you've put grams and centimeters for your unit. Why is that? Well, a number without a unit is meaningless. For example, if you asked me how much I weighed and I said, I weigh 68, you would call me a liar. But I do weigh 68 kilograms. See, a number without a unit is meaningless. By the way, if you want to find your weight in kilograms, take your weight in pounds and divide by 2.2. All right. So now we are ready to calculate the volume of the block of wood. The volume is the length times the width times the height. So we want to put 24.9 times 4.4 times 3.7 into your calculator. That gives you a volume of 405.4. Now what unit do we use this time? Well, centimeters times centimeters times centimeters gives you centimeters cubed, or cubic centimeters. That's the correct pronunciation, cubic centimeters. Now it's time to find the density of this block of wood. The density formula is on page 2 of your reference table. Here it is. The density is the mass divided by the volume. So density equals mass divided by volume. So the mass of the wood was 210.3 grams, and the volume of the wood was 405.4 cubic centimeters. Now take the mass divided by the volume and you'll have your answer for density, which happens to be 0.52. Now, what unit again? Well, grams are on top, cubic centimeters are on bottom. They don't cancel, so it's grams per cubic centimeter. All right, now it's time to find the density of the small block of wood. So here it is. Go ahead and record your mass in the table. Don't forget to put the unit of grams. Now you need to find the volume. First, measure the length. Look at the picture that's zoomed in. Make sure you record that in centimeters. Now find the width of the small block of wood. Record that in centimeters. And finally, find the height of that small block of wood. Once again, in centimeters. Once you have those three answers, you'll want to calculate the length times the width times the height, which will give you your volume. That will be in cubic centimeters. Then finally, you're ready to calculate density, which is mass divided by volume. Do that and round your answer to the nearest, to 2 decimal places. Make sure once again you include the units. Now, if you notice, these 2 answers are going to be very similar. Probably not identical, but they are very close. And so that's what should happen. The densities of this large and small block of wood should be similar. Wait a minute, what's going on here? Is that even possible? Well, remember, density is how much something weighs for its size. One piece of wood weighs less, but it's also smaller. So yes, the mass, it weighs half as much, or even less, but its volume is half as much, or even less, and it cancels out. Therefore, because they are made of the same material, their densities are very close. Now, why aren't they identical? In theory, the densities should be perfectly the same. Well, it turns out that there are slight differences between the blocks of wood. One may have more knot holes, which are slightly more dense areas. Or one of the blocks of wood may not be perfectly rectangular, throwing off our volume calculations. So that's why the numbers aren't exactly identical. Furthermore, we could have a few errors from the person taking the measurements, and that could contribute to it as well. Finally, one last question. Does cutting an object in half change its density? Well, remember, if you may be cutting it in half, it's going to weigh half as much, but it's also going to take up half as much space. So they will cancel. So does cutting an object in half change its density? No,